Good. Good. Welcome to our Google Hangout tonight. We are actually on the air. We're live after some technical difficulties with our initial plans for a livestream.com webcast. We switched to Google+. Thank you very much for joining us. My name is Daniel Skuka. I am Senior Editor for Spacecraft Operations here at the European Space Operations Center, and I am joined right now by Michel Denis, who is our spacecraft. Good evening, Michel. Who is our spacecraft operations manager for Mars Express, and we've put together. It's a little bit of a hack program here tonight, but we wanted to make sure that you got some good information coming right here from the team. We're actually sitting in the Mars Express, one of the mission control rooms here at ESOC. It's actually the mission planning room, and I'll do a quick survey with the camera if the cable will work. As you can see, we have Andy Johnson over there in the corner looking at the live telemetry coming in from the spacecraft, and we have the rest of the team are here watching. So you're actually sitting here with the Mars Express team experiencing one of the most interesting and scientifically fabulous events happening this year, the flyby of Comet Siding Spring, which just minutes ago, well, not more than an hour ago, swung by Mars Express. Michel, over to you first. How's our spacecraft doing?
Well, the spacecraft is still doing well. We have not detailed telemetry, but a signal from the spacecraft that arrived after the closest approach of a comet. And this shows that the spacecraft is continuing what it is doing now, which is a science plan.
Great. Now, if you could give us a general overview, what led us up to this situation tonight where we had the spacecraft ready for flyby? What were some of the activities in 2013, 2014 to get ready for this?
When the comet was discovered over a year ago, very little was known about it, and we had to think, what will we do? Can it be dangerous? And the assessment at the time was yes, because the scientists were taking worst cases. There's an analogy to other comets, and it was considered that the coma, so the envelope of a comet, could potentially pass by Mars and impact the spacecraft that are around Mars. So we decided, with the knowledge we had at the time, to go for preparing for the worst case, namely protecting the spacecraft by all possible means, which means putting it in the right attitude. I have a little model here. I don't know if you see it on the camera. The idea was to put the high-end antenna as a shield to the flux and protect the solar arrays that generate the electricity such that they are parallel to the possible flux of dust and micrometeorites. And if we had to do this, we wouldn't have been able to do science. Why did we do this? The estimates at the time was that on this 10 to 20 square meters of the Mars Express spacecraft, there was a danger that 1 or 2 dangerous particles could hit it and damage whichever instrument, optics, camera, or the solar electrical generators. So this is what we prepared. Meanwhile, a lot of experience, a lot of observations were made by the astronomers, and the models have been refined and refined by the scientists all over the world. And a couple of months ago, it turned out that the predictions of the danger of impact was reduced by a great factor, by about 1 million. So instead of having a dangerous particle per 10 square meters, then it would be a dangerous particle per 10 square kilometers. So this made us decide 2 things: still continue to prepare for the risky encounter should anything happen and complete it, but of course take into account the demands of the scientists and actually decide. This was decided after the process where every party involved agreed that the science plan could be done, all these observations of the comet itself, but also of the Mars atmosphere, which is being done as we speak, and we'll have the results being sent to the Earth in a couple of hours. And of course, we don't expect any impact on this small spacecraft, but Mars is a very big planet, and even with low probability of impacts, there are still some chances that the scientists see interesting effects of comet flyby.
Now, Michel, you've been with the mission for quite a while, and of course, last year in 2013, we actually celebrated 10 years of Mars Express being in orbit at Mars. Could you give us a little bit of an overview on the highlights that Mars Express has achieved in the past decade?
Okay, that's at least one big highlight per year, or sometimes several.
Yeah.
Scientifically, I mean, we can of course mention the first picture, the first color stereo picture that we've written from Mars, the first direct observation of the water on the ice caps back in 2004, more than 10 years ago. Then deploying the radar antennas, which allowed us, or the scientists, to measure the thickness of the polar caps and determine the composition of this polar cap ice, which is plain pure water practically, with a little bit of carbon dioxide ice on top of it, and measuring the depth of this ice, then one can measure exactly the quantity of water that is present on Mars. So this was one of the highlights. And highlights related to the atmosphere were, of course, the discovery, although well debated, of methane in the atmosphere of Mars. And this has gone into a low key these days, but will certainly be revisited when our next spacecraft, ExoMars, will reach Mars in, well, actually 2 years from now, because we are 19th of October 2014, and in 19th of October 2016, ExoMars should arrive at Mars.
Excellent, excellent. Now, as I understand it, you are playing a very interesting role in the ExoMars mission as well.
Yes, I am not Spacecraft Operations Manager, I'm a ground segment manager, and there is a team who are preparing for the launch in about 15 months from now. And it's all running at high speed to be ready in time, but the ground segment will be ready, and the spacecraft is, of course, under integration and testing in France and in Italy for the entry and descent demonstrator. And these things will be launched from Baikonur with a Russian Proton in January 2016. So this is all really hot.
And of course, the ExoMars science, the science to be done by the ExoMars mission is very much going to build on what Mars Express has been doing at the Red Planet.
It will indeed. And in particular, the instrument, one of the key instruments of the ExoMars, will look at the atmosphere composition, and with much better accuracy than the instruments on board ExoMars that have been designed 20 years ago already. And in particular, look for the methane or other rare gases in the atmosphere to better understand the mechanism, and well, try to find out whether there is methane and where it comes from.
Good stuff. Michelle, I'll ask you to join us again towards the end of our Google Hangout, but with your permission, I'd like to ask Andy Johnson if he's got a minute to come and join us.
Okay.
Good stuff. Thanks. Thanks. Andy, good evening.
Okay. Good evening.
Thank you very much for joining us. We're speaking with Andy Johnson. He is actually one of the spacecraft operations engineers working on Mars Express here at ESOC. And Andy has been the team lead for the last, well, I think more than a year.
Just over a year, yes.
Just over a year to actually come up with the plans, the preparations, and the actual fine details of what Mars Express was going to do to be able to handle the encounter with Siding Spring. Now, confirmation the spacecraft is in good shape tonight.
Yes, I was just checking our beacon. It's still transmitting, so everything looks good so far.
Good stuff. Initially, as Michelle was mentioning, we thought that the risk presented to the spacecraft, not only Mars Express, but the rest of the Mars fleet, the NASA and later the Indian spacecraft, was going to be much higher. Specifically speaking, what were some of the risks that Mars Express was facing?
Okay, well, as you said, initially we thought the risk would be much higher. We weren't sure what size of comet to expect. Initial estimates were anywhere between 1 and 50 kilometers to the nucleus, so we expected a much more active comet back then. But recent observations have shown that's a much smaller comet. One of the first things we did is, looked at other missions that have come close to comets and saw what environment they experienced. So one of the things that was of particular worry to us was the impact of particles. So two ways particles could affect us. There's actual physical damage from a particle smashing through components, causing damage especially to solar arrays. And the other thing is that the energies we're talking about here with 56 kilometers per second of a particle, when this hits metal, it vaporizes it. And as this cools, we get an electromagnetic pulse, and that can generate currents within wires, which could destroy them. It can also cause problems with their computers, corrupting software.
Now, is it fair to say that initially, when the Comet was thought to be much bigger, that a hit anywhere on the spacecraft was equally damaging, or how does that break down?
Not equally. What we really thought was certain sides of the spacecraft were more likely, were at greater risk from damage. For example, all of our instruments are on top, so we like to protect those, and we have various radiators all around the spacecraft. Plus, all of the components of the spacecraft are mounted in boxes to the walls of the spacecraft. Now, the only exception is this front wall here, where we have no components directly mounted to that. Plus, we have this high gain antenna mounted in front. Now, what we can do with this allowed us to basically form an improvised shield, like a Whipple shield, like they use an ISS to protect it from particles. And that was what we viewed to be the least risky side of the spacecraft, well, sorry, the least vulnerable side. And so what we intended to do is, if we look at the camera, is point the spacecraft towards the flux of the particles like this.
So if the flux was coming towards the spacecraft, away from the camera, that was going to be the safest attitude of the spacecraft.
And plus, because the comet is at its nearest point to the sun, the direction the particles are coming from and the direction of the sun are roughly 90 degrees, which allowed us to put our solar arrays edge on to the comet.
And still have full power or pretty strong power.
We get the best of both worlds, where we've got absolute minimum of cross-sectional area, where we go from about 17 square meters down to it's about 3 square meters. Plus, we get full power. We're not relying on our batteries because there's a limit to how long they can supply power to the spacecraft for.
Right. Now, Andy, I know you guys are pretty clever. I'm guessing it took more than just one meeting to organize all of that.
Yes, it's we've spent a long time analysing all the different options. Plus, we've had a lot of help from the guys at ESTEC as well, who provide us with a lot of more detailed analysis of what happened and an impact. And they did a lot of research into, again, previous missions, and they give us a lot of valuable information to analyse how big the risk was.
Right. But of course, we actually, things changed. We, as Michelle mentioned, ground observations were able to characterize further the coma and the size of the coma.
Yeah.
And this actually caused a bit of a change in your plan.
Yes, as Michelle said earlier, the estimated number of impacts was around the region of 1 per square meter. We estimated at first, which is high. But as more observations were made and the models were improved, this went down to a point where the chance of getting hit at all is quite small. There's still a risk. It never goes down to zero, but the chances of getting hit are very, very small. And so we decided that actually it's good that we can do science now.
Okay, now Andy, tell me, at 27 past, just about an hour ago now, we had closest approach of the Comet. We had closest approach with Mars Express just a minute before that. So speaking of the geometry, and then, I'm sorry? I can't hear you. Yes, exactly. We'll talk about orbit too. But we also had we've had plane crossing as well, and plane crossing represented a bit of a different threat as well.
Yes. The estimates from the models that we have was that
plane crossing being the plane of the planet itself.
Yes, so it's orbital plane. How it circles the sun. If you imagine it's a solid disk, then if we also looked at the curve of the comet's platform, then how those two cross, which isn't necessarily when the two bodies are at the closest point. So that's why we say closest approach and plane crossing.
Right, which happened just a few minutes ago.
Closest approach wasn't too long ago. Plane crossing is still coming up.
Still coming up. Okay. Yeah, I don't have my timetable.
That's right.
Okay, but we think Mars Express is pretty well set tonight.
Yes.
Even plane crossing is not.
Yes, we think the risk is very small.
It's very low. Yeah. Andy, talk to me. As my last question, talk to me a little bit. Talk to our audience a little bit about teamwork. What have you guys on the team had to go through in the last year to get ready for this?
Oh, we've done a lot of work. I mean, okay, when you said that I was putting together, I was just coordinating everybody. Every single person in the team has done a lot of work, not just in their subsystems, but just in the way we all work together, the simulations we run, and it's been pretty good for us as a team. Actually, it really has made us learn a lot about each other's subsystems and really learn a lot more about the spacecraft from the other engineers' point of view. So it's been a good experience overall, and hopefully it's going to be exciting enough to get some good science, but boring enough that the spacecraft isn't in danger.
the classic wish of every spacecraft
Yes.
operations engineer to have a boring flyby.
Boring means everything's working.
Right. Okay. Andy, thank you very much. I know
Yes, no
you're
problem.
going to go check things.
Yep.
Maybe we'll get you back and let me know if you find anything interesting
Yep,
coming in
will do.
on the team. Great.
Okay,
Thank you very much. I'd next like to ask Simon Wood, who's actually one of the team members here at ESOC, to join us, and he's just going to pass me over his laptop, and we're going to see what we can show you. Yeah, exactly. Okay, great. Good. Simon Wood, thank you for joining us. Simon's one of the also one of the team members, one of the operations engineers working on Mars Express. Simon, could you talk us through the timeline? And actually, I'll show you what he's referring to. That's our mission operations timeline for this evening. And if you could talk us through what was the spacecraft doing last week, what was it doing today, and what will it do in the next few days, particularly from the point of view of our science activities?
Yeah, I mean, in terms of obviously today's the big day, we're obviously the closest approach, but our science observations began right at the beginning of the week. So on Monday, and we've been doing one pointing towards the comet each day leading up to today. The reason we do the pointings is because, as Andy was saying, that the instruments are on the top of the spacecraft here, and they're fixed. So we can't steer the instruments. What we have to do is to point at the comet, we have to turn the whole spacecraft.
Okay.
And so we've been doing one of those a day leading up to yesterday. And that's been mostly with HRSC, our high resolution stereo camera, SpeedCam, and Omega. So it's been visual, infrared, and UV. Starting over the weekend, we've been starting doing with our radar system, MARSIS, soundings of the Martian atmosphere. So that's basically using the radar to detect any changes that may come as a result of interaction with either the hydrogen cloud or the coma, or maybe eventually even the tail. That's been going on since yesterday. In terms of what's going on right at this minute, we currently have two instruments on, and that's MARSIS, which is again doing the atmospheric soundings, because we're quite low over the surface of the planet at the moment. MARSIS has, once we get above about sort of 400 kilometers altitude, the atmospheric sounding doesn't work. And also Aspera, which is our solar wind experiment. So that's looking at how the solar wind is interacting with the Martian atmosphere, but also in this particular case, how the gas cloud and the comet is either interacting with both the solar wind and also the atmosphere. The advantage with MARSIS is that it can stay on pretty much the entire time, because it doesn't require to be pointed in a particular direction. For our cameras and for the radar system, we actually have to have specific pointings. So in terms of what the spacecraft's actually doing right now, we're actually in the middle of a slew. So we've initially done the atmospheric sounding with MARSIS, and then we're coming into a slew at the moment where the spectrometers will come on, and then they will start looking at, again, basically looking for interaction between the atmosphere and the comet. And then we have our next communication pass coming up in about, what are we at now? About an hour and a half, I guess, where we will then dump the first sets of data that we've got back today. And then following on from that, we have another pointing with the cameras, and that's going to be looking at, they're going to be looking for meteorites. So they're going to be looking for
an actual meteorite flash, an actual.
So HRSC will be obviously looking to try to take a picture of it, and then spectrometers will be looking
to
what comes off.
Get the right. That would be fabulous.
So yeah, it's in terms of the data dumps, which I guess is the sort of the next thing that everybody's wanting to know, when are we going to see some pictures?
When do we get the data? Yes.
Okay. Everything that's been recorded up until Saturday afternoon is now on the ground.
Okay.
And the reason for that is that actually Saturday afternoon is, I think as Andy was alluding to, we had a contingency plan in place, but we also have a science plan. And at some point, those two have to split.
Right.
And what we decided to do is we would do it on Saturday afternoon, because it gave us the latest possible opportunity to make any minor changes that we may have to do, and provide us with sort of essentially make sure we were as flexible as we possibly could be.
Right.
So the main issue that we have actually in terms of getting everything down is that as we've said before, instrument is fixed to the spacecraft, so is the high gain antenna. So to transmit the data, we have to point at Earth. Therefore, we're not pointing at the comet or Mars to take observations. So it's quite a challenge in the sense that we generate far more data than we could possibly, faster than we could possibly transmit it.
Right.
So we're having to store it on board, and then we have various systems with the mission planning systems that we've got over there that are able to prioritize the data downlink based on how much data has been generated, what instruments are producing it, and where the opportunities are to transmit. And so, because at the moment, whilst we have the cameras on, they actually produce we're actually producing very small amounts of data at the moment for each observation. So something like Marsis, which is on for a good few hours at each point,
produces quite a lot of data.
So the current downlink plan essentially prioritizes Marsis. So I think most of the HRSC pictures will be down probably Thursday.
Okay, so mid to end of next week.
Yeah.
And of course, the scientists still have to receive that data, do their processing, do some initial analysis, and we'll get them sometime after.
Yeah. So, and then into tomorrow, it's mostly there'll be a few more attempts to image the comet, but also it's going to be mainly looking at the atmosphere, because obviously if there has been any interaction between the atmosphere and the comet, I mean, there's one suggestion that maybe it's going to heat up, maybe it expands. Then they'll be interested in not only what happens right now, but then obviously what happens as the comet has gone past. Does it shrink back, and that kind of stuff. And then I think that goes right away into Tuesday. So it's a whole sort of over a week's worth of observations.
So it's not just a simple flyby. It's here, it passes by, it's gone. We're actually working on this for quite a while.
Yes.
Yeah. Okay. Final question, Simon. What about the stations? We have some ESA stations involved. We have some NASA stations involved. What are some of the stations doing for us?
Well, for the immediate point, like today, what we've got is we've got 2 DSN stations. So we've been quite lucky in the sense that
those are the NASA stations.
The NASA stations, yes. So NASA have effectively dedicated 2 entire sites to pointing at Mars today, because obviously we're there. They have their own orbiters. There's the Indian spacecraft as well, MOM, and so we've been using their ground stations to receive our S-band beacon today. We'll also be using them to dump the data as we have it now. In addition to that, because as part of the contingency plan, we have to sort of factor in that maybe we will need to command the spacecraft, maybe we will need to do something to sort out any issues that we might run into. We've got S-track stations, the ESA stations in reserve, but also we're now going to use them just for normal operations. So we come over range in Malague in Argentina in a few hours' time. We have our first ESA station pass just after midnight at New Norcia. And then we have a few more dual setups over the next few days. That actually, from a planning point of view, has actually been quite tricky, because it means we've had lots of overlapping stations, and in some cases 2 or 3 stations booked at the same time. And our planning systems here are specifically designed to prevent us from doing that.
Sure.
So it's been a lot of kind of manual intervention.
Normally it's 1 station if that. Yeah. Good stuff. Simon, good stuff. Thank you very much. I'll let you get back to things, and thank you very much for joining us. Okay. I'll just mention, if anyone has any questions, they can actually put them into Twitter. We're watching ESA Operations at ESA Operations, and you can address them to that Twitter account. You can also use the hashtag #MarsComet, #MarsComet, and if we see any questions coming up on Twitter, we can grab those and see if we can answer them. Okay, I'll just see if Michael Kahn is available. He thinks he might be. Good stuff. Okay, you're a little bit more my height, so I think we can both sit up straight. That's good. We're speaking with Michael Kahn, who is actually working here at ESOC in our mission analysis section.
Right.
And Michael, you've actually done a lot of work looking at how some of the ESA missions, some of the planetary missions are planned and developed. We're very interested tonight in comets. It seems to be the season of comets. Next month we have Rosetta delivering a lander on 67P. What can you tell us about Comet Siding Spring?
Comet Siding Spring is a comet that comes from afar, and that's not going to come back probably. It's a hyperbolic comet. It comes from perhaps as far out as 1/4 or more of the distance to the closest star. So it's really, really really ancient, and it's full of material that probably was just as it is now, so it hasn't changed since the solar system was since the solar system formed.
Right. Have we ever had a chance before to look at a comet, at one of these very ancient Oort cloud comets from so close? Is this something we've done before?
No, this is a very unique occasion. There has never been such a close planetary flyby. There was a comet in 1770 which buzzed the Earth at 2.3 million kilometers. But of course, we didn't have a spacecraft. But also, the distance was much larger.
The distance was much larger. What are some of the things with our instruments on Mars Express, as well as our ground-based observations, and of course, we have the fleet of spacecraft. We have the NASA spacecraft as well. What are some of the things that scientists hope to learn about Siding Spring?
Every cometary encounter brings information and data, and this is just a serendipitous occasion. So you just take any advantage of this that you can. So what they're trying to do, and it's already been mentioned, is to see whether they can see the coma and detect the elements in there, the chemical composition. This prompt is just see its form, its shape. With the cameras, they perhaps can see meteors on the surface. They can see some changes in the magnetic environment surrounding Mars. All these things are informative, and they just give little puzzle pieces. Yeah, they just give more information, and they help us understand a bit more what these mysterious objects are.
Right, and how does Siding Spring compare or contrast with 67P? Obviously, there's a big difference in size. 67P is
4 kilometers.
4 kilometers, and the nucleus of Siding Spring is thought to be something like 700 meters. So there's obviously a big size difference. What are some of the other differences?
The main difference is the orbit. As I mentioned, Siding Spring comes from the Oort cloud, so really far out. And 67P is a Jupiter family comet, so it has a period of about 5 years, and its farthest point is never farther out than the Jupiter orbit, so it's quite close, quite a lot closer. And so the difference is that the 67P has really passed by the sun a couple of times and really lost some of its material and been shaped by the heat. So that makes a big difference.
Good stuff. And actually, just with the word of the future, you mentioned that we're not going to see Siding Spring again. It's going to go back to where it came from. What are you going to be looking for when we finally do touch down on 67P next month? What's your own interest in? What sort of information and data are you hoping to see?
Well, first of all, it's the stark, strange beauty of these objects, and really, I find these images we've seen up to now wonderful, totally different from what I expected. But of course, we don't really know also the surface composition of a comet. There's been lots of conjecture, and hopefully the conjecture about the ability of the surface to hold the landing craft that will be deposited in November is sufficient, or is correct, it's sufficiently close to the truth.
Good stuff. Michael, thank you very much for joining us tonight, and best wishes.
Thanks.
Thanks. Okay, we're going to take a short 2-minute break here in our Google Hangout. We'll turn off the mic, and we'll leave the video live. Don't go away. We'll be back in about 2 minutes with a final report from the Mars Express planning room here at the European Space Operations Center, and a wrap on tonight's Siding Spring flyby. European Space Operations Center from the Mars Express mission planning room, and I've asked Andy Johnson, our spacecraft operations engineer working on the mission, one of the team members working on the mission, to join us again. Andy, thank you.
Yeah, no
and give us a quick update on what we've seen coming from the spacecraft in the last half hour.
Well, at the moment, okay, we still have no telemetry. That's normal. That's what's expected right now. The beacon shows everything is still good. We saw a small increase in the signal, which means that we are slewing as expected to point to our next target. But very shortly, in 5 minutes or so, we're going to lose the signal because of the way the spacecraft's turned. Again, this is expected. And then that will be us through to in about an hour or so, when we will get full contact with the spacecraft, and then we'll be able to tell everything is okay.
And when you say full contact with the spacecraft, you mean both S-band and X-band, which is actually the high bit rate?
Yes,
the actual,
we'll actually have telemetry, so we're able to get an actual detailed pictures of what's going on board the spacecraft.
Right, good stuff. Okay, and you're going to be watching here for another couple of hours, I'm
I'll
guessing?
be here for a long time. Yes.
Okay, good stuff. We may get you back on again. Thank you very
no
much.
problem.
Okay, thanks a
Okay.
lot. Thanks. Good. We've been taking a peek into Twitter and, of course, in the YouTube channel and the YouTube comments underneath our video tonight. And we've seen a lot of really good questions. We're going to try and see if we can answer a few of them. Unfortunately, we won't be able to address all, and we won't be able to send you individual responses, but we'll see what we can come up with right here in the Google Hangout. And actually, I guess I'd like to ask Simon to rejoin, if he could. And again, I'm introducing, in case you missed for our first half of our program, Simon Wood is a spacecraft operations engineer working here on the team. Thanks for joining us again. Simon, we've had a few questions, and you addressed a couple of these points in the first half of our program, but the questions come up again. When do we see images, and when do we get first results?
Right, well, I mean, first images, it's as much down to our science teams as it is us, really. I mean, what we're in charge of basically making sure that the data gets down to the ground.
Well, to talk us through that process. When will we get the data that was recorded this evening? When will it actually get down to the ground?
Okay, well, as we've said before, I mean, the observations have been going on all week, and so everything up until Saturday afternoon is now transmitted, and that's now on the ground. In terms of images, I mean, I guess we're effectively looking at HRSC, so the actual pictures that we're taking of the comet, and those are scheduled to be dumped on Thursday afternoon, and that is, as we said before, I mean, the instrument package is fixed, the antenna is fixed. We can't point at Earth and take observations at the same time.
It's one or the other.
Yeah, and so we have to prioritize the data dumps based on the amount of data that's being generated and which instruments are generating it, because otherwise, we only have a finite amount of storage space on board, and each instrument is allocated a set amount of that. And if they overfill it, then what happens is that they go back to the beginning and start overwriting old data.
Ooh.
So we have to make sure that we dump everything. We dump data off the spacecraft fast enough that overwrite doesn't happen. And the objective really with Mars Express has always been that we get all of the data, not necessarily it immediately. And the scientists at the end of the day would rather have all of their data than a couple of bits of it now but have to lose it. Right. And so if we were, for example, to try and dump HRSC images right now, we would actually lose some of the data coming from the radar.
Right.
That would be overlooked.
Right. Okay, so next week we'll get some of the data coming down, and then gets past the science teams. They'll do their analysis, their processing, and then we'll get the data. We'll get the images.
Yeah. I think also the thing to remember is that, I mean, okay, well, everyone wants to see some nice pictures of this, but it's some of the real interesting science is going to be the stuff that isn't very visual. Right. It's going to be the spectrometers. It's going to be the stuff coming from ASPER. It's going to be the radar soundings. So right. And that's not something that takes 5 minutes to process. And it's going to take quite a long time to go through all of it, especially because I think at the end of the day, no one's really quite sure what they're going to see. Right. So as Mikhail was saying, we've never had this before. We've never had a comet fly this close to a planet, let alone something from the Oort cloud. Okay.
Good stuff. Actually, I'll swap you up for Michael now. Thank you very much. There he was trying to sneak out and go for coffee, I think. Michael Kahn, mission analyst here at the European Space Operations Center. Thanks for coming back on our Google Hangout. I'm looking at a number of the questions that have been posted in Twitter and YouTube, and one of the ones that has come up is, what do we expect to see in terms of the images? What do we think that HRSC might be able to have seen during this flyby of Siding Spring?
My understanding, the HRC has been that SRC, so Super Resolution Channel, has been taking images of the comet as it approached. So we should see the coma, we should see the tail as it spreads out. Should be a dramatic view. Today, perhaps we should see details of the coma. And then tomorrow we see the comet receding in the distance in the opposite direction. But, fact is that the activity of the comet has been decreasing, so the comet is losing steam, so to speak. This is strange because it's approaching its perihelion, so it should be getting more, not less active. So why this is anyone's guess, and perhaps we find out why.
Perhaps Mars Express will help us solve that mystery. Speaking of mysteries, there was a question coming in via YouTube, and it's on the origin of water. And will the data coming from the Siding Spring flyby help us understand the origin of water? And of course, this is referring to where the water comes from on Earth.
We have good indications that a sizable percentage of the water on Earth does come from comets, and this happened in the very early stages of the solar system. And I'm hopefully we will get some more information on that, but I think we don't at this distance, and the experiments are not made for that. It's not a comet probe. We might not have a sufficiently high resolution of such details as isotopologues. It means exactly which kinds of, which types of which every atom do we have, element do we have on the comet. For that, I think the right spacecraft to ask is Rosetta.
Is Rosetta coming up in about a month's time? We're actually less than a month's time now, right? Another question that was posted on YouTube, Michael, was could the comet have broken up going by Mars tonight?
If it has broken up, then that should have happened sometime earlier. But if this receding activity comes together with a breakup, that would be really strange, and that would mean that there's going to be nothing left of the comet afterwards. I hope not. I don't know. Normally, if you see a breakup, it coincides with an increase in activity.
Okay, but certainly at the distance that we're approaching Mars, 139,000 kilometers, that's actually quite far, and the gravitational effect shouldn't have been...
No, if it has broken up before, that would not have anything to do with the flyby, and I don't think this flyby is close enough to cause tidal effects large enough that they outweigh the much larger internal pressure that comes from the heating.
Good, right, okay. Another question is on this comet, Siding Spring, comparing its orbit to that of the very famous comet Shoemaker-Levy, which had a big planetary impact. Could you mention a little bit about the differences between the two comets and their orbits?
Okay, that's Shoemaker-Levy 9. That was actually in orbit around Jupiter, so it was captured by Jupiter, and then it performed I think more than one complete orbit around Jupiter before, due to perturbations, its lowest point, its point close to Jupiter, had decreased, and then it had been broken up due to tidal effects. So that was exactly this effect we're talking about. But Jupiter is much larger than Mars, and it's you can't compare these scenarios. And then all these bits that had been generated by the breakup hit one after the other, impacted Jupiter, and created a chain of impacts on the surface. But to be captured by Jupiter, the comet must have approached Jupiter at a much lower velocity. Otherwise, it would just have been destroyed and sent somewhere else in space. It would not have been captured. It must have had a very low relative velocity. And so that's called a gravitational capture. And that's not possible for a comet that comes out from that far out.
So Shoemaker-Levy was not an Oort cloud comet. It was not coming so fast.
Right. It was probably a centaur, a so-called centaur. That's an orbit that comes from the Kuiper belt. So it's just beyond the Pluto orbit, and was probably sent down to Jupiter via several swingbys at Neptune or the outer gas giants, which successively changed its orbital elements.
Great. Okay. One final question for you: is there been any evidence that you've seen so far? Any images that you've seen for fragmentation of Siding Spring? And obviously, we're still waiting for data from tonight from the closest approach. But is there any evidence for fragmentation or breaking up of the comet?
As I said, fragmentation normally goes with an increase, not a decrease in activity, and also. Well, I don't know. Again, we don't really know about these really small comets. Yeah, this is also kind of a first that we see such a small comet have a good chance of observing it. if a larger comet breaks up, then all these individual parts make up smaller comets of their own. So you start seeing then a cloud of comets. So each of them has a different, separate comas and tails. I don't see any evidence of that here.
Great, good. Michael, thank you very much for answering some questions. And we're just about coming to the end of our Google Hangout tonight. To confirm, our spacecraft Mars Express is in excellent shape. And I'm going to ask Spacecraft Operations Manager Michel Denis to come back into the hot seat here on the camera. And I'm a little taller than Michel, so I'm just going to slump down just a little bit, and then we look okay on the camera. Michel, could you give us a wrap on the evening? How has it gone, and what's coming up next?
Okay, so far it's gone very well. We continue seeing the little beacon, the S-band signal from the spacecraft, although the spacecraft is not pointing directly any antenna to the Earth, but from this omnidirectional small antenna, we can track the Mars Express. And if I look over there, I can still see it. Although at the moment the geometry is unfavorable, actually part of this antenna is masked by the solar arrays of the spacecraft. So we're just lucky, or actually our colleagues from the DSN use very powerful radio science receiver, which can track extremely weak signals. So even if the signal is disturbed by the presence of the spacecraft and the solar arrays in front of the antenna, a part of the signal still reaches the Earth and can be tracked by this. So which will allow us to follow the rest of the encounter up to the plane crossing. The colleagues have talked about the plane crossing, which will occur at the spacecraft, well, roughly now, actually, in a few minutes. So we'll know within 10-15 minutes that also that part of the overall event has gone successfully. Okay. And then within another hour or so, then we will have again the spacecraft pointed to the Earth, and as we said before, sending the data and the first images or observations from the encounter. So then not only will we receive science, but also we will have a full visibility on the spacecraft, and it will be a bit late here in Europe, but we'll still have a quick look to be sure that the spacecraft is in the shape we expect it to be. It's very likely. And the next few days, we will be doing some checks on the computers, on the onboard memories, just to be sure that even if we have not seen anything, there has been no disturbance somewhere in the memory where a bit has been flipped, a 0 became a 1, a 1 became a 0, which could be a problem if we would try to use this software or reload it, maybe in months or years. So we will be, as we say, dumping, we will be checking all the memories on board the spacecraft, all the permanent memories, which are dormant, and just to be sure that there is no hidden bug induced by the passage of a comet. And if there is an anomaly, we'll correct it, of course.
Good stuff. Michel, it's been a long haul to get the spacecraft ready for tonight. You've obviously done everything very well, and the team has done an excellent job. Certainly, it's probably time to pass on a thanks to the entire team for getting us to this stage and getting us through a very interesting flyby.
Yes, this is the big thanks to the team, to the people in this room, and some who are not present, cannot be present tonight, but we'll continue the work as from tomorrow. And indeed, everybody has been working very, very hard for an event which is special. In space, there are always special events, although spacecraft are made for routine and exploiting data and making overall surveys of a planet or another body. Now, when comes a special event, the motivation rises again, in a sense. So this is good for the team morale, and this is good for the expertise, because then we regain expertise in our detailed procedures, in what to do if things wouldn't go well. So we prepare, and we prepare better when there are special events. And a couple of times in the past, we have been close to maybe having serious problems with spacecraft. Once was due to a big solar flare, so a big event coming from the sun. We have had events linked to deployment of radar antennas. We have had events linked to passing by Phobos, or Phobos passing in the field of view of some cameras. So we have had disturbances, because in space there are all sorts of things happening all the time. and from time to time having one which, let's say, forces us to rethink and not be only doing routine is a good thing. And well, okay, in 1 or 2 hours we'll have a final confirmation that everything was okay. But so far, looks very good. So thank you, everybody.
And of course, it's not just the team here at ESOC, or not only just the flight control team here at ESOC. We have teams of specialists at the center who are assisting Mars Express. We have the flight dynamics teams. We have our STRAC stations. We have a number of other functional specialties here at ESOC who have been assisting tonight. And of course, we also have the scientists and the science operations teams at ESOC. Of course, we haven't heard from them